Number one says infrared waves are transverse waves, and we're required to complete the sentence. And the sentence says, in a transverse wave, the direction of oscillation is blank to the direction of energy transfer by the wave. Infrared radiation is an electromagnetic wave, and all electromagnetic waves are transverse. The direction of oscillation is perpendicular to the direction of energy transfer, compared to longitudinal, where the direction of oscillation is parallel to the direction of energy transfer. Next question says, a student investigated how the color of a surface affects the rate at which the surface emits infrared radiation. Then it says figure 1 shows some of the equipment used. In the question, we have the silver colored flask and then black colored flask. The student wrote the following hypothesis. The black colored flask will emit more infrared radiation than the silver colored flask during 10 minutes of cooling. That's a hypothesis. It's on us to either prove or disprove that hypothesis. So we're required to describe a method to test that hypothesis. Is an extended response, required practical question, a 6-mark question, and then for your 6 markers they have to be well detailed. And some of the things that you need to have a level 3 response that's at least get between 5 marks and 6 marks is that your method must be logically sequenced in terms of your steps, and then it must clearly show how you would measure a decrease in temperature for both flasks over 10 minutes. Then you compare. If you simply just list the steps without showing logical order, you're just going to get maybe a level 1 or a level 2 answer. But that's not the goal. The goal is to get the highest marks possible. And then the key physics here is that dark matte surfaces are actually better emitters of infrared radiation than light shining surfaces. But let's prove it. That's from your theory. Let's prove it. So how do we perform the experiment? Well, number one, we heat water in that kettle in the diagram, and then we add an equal volume of hot water to both the black colored flask and the silver colored flask, and that is going to ensure a fair test. All right, so both flasks starts with the same thermal energy. Step 2, we record initial temperature. So we insert a thermometer, or it could be a thermometer probe, into each flask and record the starting temperature of both flasks. Step 3, you start the timer at the same time for both flasks. Step 4, you record after 10 minutes. So after exactly 10 minutes, you record your final temperature for each flask. Okay, I mean the final temperature of the water for each flask. And then step 5, you calculate the temperature change. So you calculate the temperature decrease, that is your initial temperature minus your final for each flask over the 10 minutes. A larger temperature drop indicates more heat has been emitted as IR radiation. And then the last step that gets you your final mark, that is you compare the temperature change of the black flask with that of the silver flask. If the black flask shows a greater temperature decrease, that means the hypothesis is supported. Now, in terms of some of the variables needed here, you have 3 control variables, just an added knowledge for you here. Control variables are variables that we keep the same. In this case, you have the volume of water in each flask has to be kept the same. The starting temperature of water, like I said earlier, has to be kept the same. The distance of IR detector from flask has to be kept the same. Why? Because, the IR intensity follows an inverse square law with distance. So by the time the distance changes, the IR intensity is going to change as well. So we don't want that kind of thing to happen in this case. Independent variables are variables that you deliberately change in an experiment. And in this case, that's the surface color of flask, the black or the silver. And then the temperature change, that is your dependent variable. That's the variable you measure. That's the purpose of our experiment. And then question 3 says, when will the flask emit infrared radiation at the greatest rate? Give a reason. Now, we know that the rate at which an object emits thermal radiation depends on its temperature, more precisely on the temperature difference between the object and its surroundings. So at the start of the experiment, that's the first minute, the flask contains hot water and the surroundings are at room temperature. That actually gives the largest temperature difference, so the flask radiates energy more rapidly. And as the water cools, that is from your 5th minute to your 9th minute, the temperature difference actually shrinks. So the rate of IR emission decreases. And by the 9th minute, the flask is much cooler to room temperature and emits much less radiation. So basically, the rate of heat loss is proportional to the excess temperature above the surroundings. So the answer to question 1.3 is during the first minute. And what's the reason why you get the second mark? The temperature difference between the hot water and the surroundings is greatest at the start of cooling. So the rate of energy transfer by infrared radiation is highest. I'll see you in the next video.